Okay, so now we're on station 8, short circuits. So what is a short circuit? So you'll see here on your booklet that there's 5 steps, 5 questions, however you want to look at it. Now on the first one here, it's just basically explaining how to set up this circuit. I've already done that. Alright, now I'm going to go through, I'm going to test the circuit, make sure it's good, and then I'm going to show you what a short circuit is and the cause and effects of it. And you'll see in step 5 here it says to discuss the dangers and such of a short circuit, but also you might want to encumber in that discussion what are some of the positive effects of it. And I'll touch on that after we do the demonstration here. Okay, so now I'm going to connect the ground to the battery. Again, we still have all the same parts. We have the battery, the positive, the ground, the black, okay, and then you'll see I got these green wires here which I'm using for the circuit. I've connected it up, the bulb is illuminated. Now as in the diagram there, it tells me to take this small piece of wire and to connect it between these two. And at this point, if you want, you can pause the video and maybe discuss with the kids what's going to happen. Okay, so now let's do it. I'm going to touch the wires. Watch the bulb. The bulb goes out. Alright, so I'll do that again. I'll release it, and then I'm going to touch the wires. It goes out. Alright, now if I leave this here, alright, you'll notice that they start getting warm. Okay, now I know that you're just watching the video. You could probably try this in your classroom. But if you leave it there, like I mentioned in station 1, where we touched on the short circuit, if you leave that there long enough, this wire will get hot enough where it'll start to melt that casing. And now if that thing, this casing, that wire, is near anything flammable, it potentially could ignite it. Okay? So there's some of the things that you can discuss in question 5. Also, why does the bulb go out when I touch these wires? Okay, why would it do that? Okay, the thing you need to understand with electricity is it likes to flow through the path of least resistance. Okay, so when the electricity flows through this bulb, that bulb is actually a load or like a resistance. Okay, and we cover what resistance and conductors are. So this bulb is sort of like a semiconductor, and then it goes through there. It lights up, so there's resistance there, creating heat, because everyone has touched a light bulb, you know, it gets hot. Alright? This wire doesn't have any resistance, so it has less of a resistance to travel through, so electricity likes to flow through the path of least resistance. So now the electricity is flowing through the green wires, through the white wire that I'm connecting here, and then back around through the ground, alright, which is eliminating or shorting out the bulb. Okay, so that's what a short circuit does. Now there's a lot of bad connotations to a short circuit. It can cause a fire, burning, those sorts of things, but you can also use that in a positive aspect. There's a test you can, or call it a test, that you can do, that you can get some steel wool and you can connect the steel wool between a battery positive and a battery negative, and you'll actually see it sparkle. And if you have the right amount of combustible material there, be it paper, wood chips or something, you could start a fire. Okay, so that's a positive effect, that you could start a fire with a short circuit. Now I'm not suggesting you do that in the classroom, and you don't want to do that with supervision. Okay, so go through the questions and have fun.